I've previously shown you how you can write a chapter of your own visual novel using a chapter file method in a text editor. This involves each piece of dialogue being a separate line in the file. But there is a way we can simplify it and at the same time add even more features. This new method will allow us, instead of separating dialogue into multiple lines, we can have all dialogue in the same line, just separated by certain tag commands that tell us to wait for input to continue. We can do this as long as all of the dialogue of a line belongs to the same character. Before we get started, we need to understand the two types of items we'll add to our lines over the next 2 episodes. Lines will contain 2 types of data among its dialogue. There are segmentors, and then there are events. The difference between the two is very simple. Segmentors segment an entire string of dialogue into 2 or more pieces that are fed through the dialogue system in turn, following the instructions of the segmentation type. An example of some segmentors would be to wait for user click then append, wait for set time and append, and so on. Those 4 are all I have in mind right now, but all segmentors will be contained inside of squiggly brackets. Events don't divide text into any additional parts. Instead, what events do is tell the dialogue system how to behave. For instance, an event could change the rate of dialogue character generation. It could be an injection for a special name like a main character or an item, or it could literally be anything else. Those are just examples of what an event will do. As long as you can code it, you can make whatever event suits your visual novel. And if you decide to use this dialogue system for a game and not a novel, then events will potentially be even more useful to you. So we're going to focus on commands today. We'll be amalgamating all the separate lines of a single character into one smarter and more convenient line today. So let's talk about what kind of segmentors I'm going to create. So commands in dialogue. As I said, they'll be identified by squiggly brackets, and they will identify an expectation of some form of input before continuing to the dialogue that precedes it. Since these lines will be something used very frequently, you want them to be as short, painless, and yet as easy to remember and distinguish as possible. For me, these will be my 4 segmentors. C will mean to wait for user input and then clear or override the current dialogue with the next. The letter A will mean to wait for user input again, but this time don't clear, append the text, or make it additive. The W means to wait for a set amount of time and continue automatically. This also overrides the previous text, whereas WA means to wait for a set time and append the following text. You can see my segmentors are super short and simple, so it'll be effortless for me to use and remember these things. I recommend the same practice for you. So this is what multiple lines joined by segmentors looks like. But when we apply this and run the line in Unity, the dialogue system doesn't know how to interpret it, so we get it verbatim, and that's not what we want. In this case, that is definitely not what we want. To make this work, we need to understand exactly what a line is. A line is a string of dialogue and actions, but more specifically, a line is a container of 1 or more dialogue segments, and that's what we want to retrieve. We want to divide the line into segments and feed them into the system one at a time. So we essentially create multiple lines from one line, and then just permit or deny them based on the satisfaction of the segmentation trigger, which is my single to double character command. So let's get started by jumping right into Unity, and to keep things organized, I'll create a subfolder in my core specifically for the novel controller scripts. Then I'm moving my novel controller inside of that folder. Inside, let's make a new script to handle the segmentation and operation of line elements. Since this is directly related to my chapter files, I'm just going to call it my Chapter Line Manager, or CLM for short. So we know we need something to represent a segmented line, so let's make a class for that. And a line consists of segments, so let's make another class for that. Now to segment from anywhere, let's make a public static function called interpret that will take a raw string and convert it into a usable line for us. A raw line is simply a line directly from a chapter file that may or may not have segmentors inside of its dialogue portion. And we'll need a way of converting it, so the most convenient way I know is to initialize a line when creating it. Give this initialization the raw line we want to convert. Now in Interpret, we can just return a new line using the raw line. Now let's reference back to our novel controller and split the dialogue and actions from each other. Load the controller, and take this split here and paste it into our CLM. Replace line with raw line to split the dialogue from the actions. And we'll also want to split all of the actions from each other, if there are any available. And actions, as you remember, are just separated by a space, so that's our splitter character. Then make the array for the actions and split them. Remember that dialogue and actions array will have a length of 3 if dialogue is used. There will only be a length of 1 if there are only actions. So split it based on that index. Now comes time to segment the dialogue, and we can only do it if the length of our split line is 3, meaning there were quotation marks and we have dialogue in here. But we're going to need some variables to store information in before we do that. So we know that if a line contains dialogue, then it's most likely going to have a speaker, so let's make a string to store the speaker. And as we've established, a line of dialogue consists of one or more segments, so make a list of segments for this line as well. Then if there are any actions in the line, we need to store them in a list. This will be important, especially for a feature we're going to cover in the next episode using tags. Once we've got all that, we're ready to get our speaker. But sometimes a speaker won't always be given. It's then up to our line to get the last known speaker. This means we have to access the novel controller's cached last speaker, which currently isn't a public variable, so let me change that right now. Now retrieve our speaker as the first element if it's not empty. If it is, then fetch the cached last known speaker. And it appears I don't have an instance set for the novel controller, so let me fix that right now. We'll say public static novel controller, call it instance, and then as usual, I will assign that to this current instance in awake. Alright, there we go. And don't forget to remove the space after the character name if one is present. This comes by having a space between the character name and the dialogue they use. In other words, the character name and the beginning of the quotation marks. Then we need to update the cached last speaker. Once that's done, it's time to segment the dialogue. So let's make a function below to do this for us. This will take the dialogue directly and give us a list of segments in return. Clear the current segments first, that way we start fresh. Then split the dialogue by the command brackets. This will give us the dialogue and the command segmenters in an array. Now increment through each item in the array using a for loop. Segmenters will always be odd indexed, so that's how we'll know when to start a new segment. Create a new segment by saying new segment. If we're on an odd index right now, then we need to interpret the segmenter and determine how this new segment should be triggered. Some segmenters might have data with them, like my wait segmenter. It has a time value that I should wait for, so I'll get both the segment title as well as any potential data split by a space character. Then switch based off of the title. I've got 4 segmenters currently, so I will need 4 cases. And in the actual segment class, we'll also need to store some data now. I want a reference to the line the segment belongs to, and I will want the dialogue of this segment, the pretext if it's additive, or even just a boolean saying if it's additive or not. Either way will work. Then this is the important part. The trigger is what tells the segment when to start. There are 3 triggers, although really only 2 if you think about it. Wait for user click and append, which those 2 could be combined, then wait or auto delay. So now make a trigger and give it a default value of wait for click. If the trigger needs to wait for a certain amount of time, make a storage for the time as a float. Okay, now we can make our triggers in the case. C means to wait for click and clear the dialog box, so I'll set the trigger to wait for click. A means wait for click and append text, but it should still use the same trigger as C. Make both of them simply wait for click. And both W and WA need the auto delay trigger. They also need the time stored in their auto delay float variable. Get it by parsing the second item in the command data as a float. And repeat for WA, or whatever your segmenter would be. But with appending triggers, we need to set the pretext variable. If you made a boolean, simply set it to true and the dialog system will automatically take care of it for you. If you made a string that you can reference at any time, fill it with the preceding segment's dialog. And make sure to do the same with wait and append, or WA. Moving on, it's important that we increment by 1 after the trigger. It's set so we can move past the segmenter into the next bit of dialogue. Then assign the dialogue of this segment to the current dialogue in our array. And set the line from here as well. Then add this segment to the segments list, and so begins the construction of our first line element. Now we can come back up to our line initialization and call the segmentation function to build the segments of our line. Pass in dialogue, and we are good to go. That will now make all of our segments for us. Next, we need to assign the actions to a list. We already have them in an array, but we'll want them in a list for when we start using tags, and you'll understand why next episode. So just loop through the array and add each element to the actions list. There we go. Looks good. That's all we need to do here, so now let's head over to our novel controller and make it use these new lines. Alright, let's start by removing this little bit in update. That's no longer going to be valid. Then remove progress from the chapter loading. Handle line is going to take a raw line and convert it into an actual usable line. So we can change that to raw line there, be more accurate. So get rid of all of this here and create a new line, saying clm.line equals new line, or interpret, because we are interpreting a raw line. Now let's make a coroutine for handling a line. The coroutine should take the new line as its parameter, then make the coroutine reference and a boolean to show its status as active or not. Now make a function to stop the coroutine and reset it. Okay, so if we're handling a line, then stop the coroutine using our new stop function and start up a new one, giving it our line reference. Alright, so now let's just clean up the script by removing a few functions we don't need, since we're using CLM now. Handle dialog will be handled by the segments, so we don't need that here. And handle events will be taken care of by the line itself. Since the actions are already in the list and the line, we don't need that anymore. Alright, that's it. That's all we need to remove. Just separate it there. And now we're almost ready to make our lines work. But first, since a line is just part of a chapter, we need to handle the chapter file before messing with any lines. Sure, we've already loaded the raw lines from the chapter file, but we need a way to progress through them all and handle each one as a line element. So let's make one final coroutine to handle our chapter file. This coroutine is what will initiate our handling line coroutine for each line in the file. To start it, let's initiate the coroutine whenever we load a chapter file with our file manager. Stop the coroutine if it's already running so chapters don't overlap. And start the new handle chapter method. Now we can make an internal integer called progress to keep track of our current line numerically. Since data is what's loaded from the file manager, we need to loop until our progress surpasses the data count. Please yield immediately and save yourself from a bad loop. I have done that way too many times. Now, first and foremost, we need a way of knowing when to progress to the next line. This should be an event triggered by the player either clicking a part of the screen or pressing a button. So let's call this event a next trigger to be very simple. The next trigger should be a value that can be changed by any number of methods, either by keyboard, mouse click, or what have you, so let's make a function that can be called both in and out of script. The trigger will be represented by a private boolean called _next. And it will be set to true only when the function called next is triggered. So if the chapter file handler detects this trigger, it'll begin handling the next line. Call next on the start of this function to make the first event trigger automatically. After the line begins, increment our progress by 1 and yield until the line completes. And how do we know if the line is complete? If the isHandlingLine boolean is false. Alright, good, and that will take us from the very beginning of a chapter all the way to the end of it. It waits for that trigger, and that's what initiates each event. So now that lines are supposed to be handled, let's actually make that happen. The chapter manager calls to handle a line, at which point a line is created from the raw data and the coroutine begins. Since the next trigger also controls the flow of segments inside a line, we need to reset it to false at start. Now make an integer for the current progress through the segments of our line. While that progress is less than the total number of segments in this line, loop and yield. Again, since this loops, we need to make sure the next trigger is false upon every loop start. Capture the current segment to be constructed. That would be a segment. The first segment of a line should always start automatically, but every other segment must be triggered by their own rule set. So if this is not the first segment, then we need to wait for the segment to be triggered. Remember our two triggers, wait for click and auto delay. If this segment's trigger is auto delay, then we need to yield for a certain time. If we wait for click, just loop and yield until the next trigger is set to true. When it comes to an auto delay, we can't just yield for seconds, which would be the easy thing to do, but we can't do that because we want the next trigger to interrupt this delay and force the segment to begin ahead of time. Because of that, we'll use a for loop, decreasing the time by delta time each frame until we reach 0. This simulates wait for seconds, while allowing us to monitor each frame, and that'll allow me to check for the trigger and break the delay prematurely. I do this in case someone rapidly presses their proceed key, and that'll trigger the next event and break a delay. After this section, we know our segment has been triggered, so set next to false just in case it was used and we're ready to continue. And now the segment needs to build and run, but I don't want to make this script messy, so let's make each segment handle itself with a run command. Back in our CLM, scroll down to the segment class and make a function called run. And call run from the novel controller. You know by now I really like coroutines, and of course we're going to be making another one to control the run. Give it a coroutine reference variable as well. And a boolean so we know when our segment finishes building. Inside run, stop a running loop and start a new one. If run is not null, then stop it and set it to a new instance of the coroutine. Now comes the dialogue system's turn in all of this. If the speaker of this line is the narrator, use the dialogue system directly. Otherwise, use the character manager to make the characters speak. For the additive boolean, if you used pretext as a boolean, just pass it in. But if you used a string, then set it to true if the pretext is not empty. Now we yield until the dialogue system finishes displaying the string. And how would we know this? We would check if it was speaking as true, but instead I want to access the dialogue system's current text architect and monitor the isConstructing boolean. The reason for this is our novel controller will want access to it as well for certain triggers, so we'll kill two birds with one stone if we go ahead and cache the architect in this segment. Then end it by setting running to null. And back in our novel controller, while the segment is running, yield. But now we can check for the next trigger to auto-complete the architect and skip to the next segment. But we need the segment's architect to be public to make use of it. Currently, right now, I don't think I did that. And I did not. There, public. So if the architect is constructing the first time we hit the next trigger, make it skip and show text faster, but on the second trigger, force it to autocomplete. That is my personal taste. You can do whatever you want, but we haven't made this function yet, but it'll be called force finish. So let's jump into the CLM and make that function. Force finish will be a public function that forces the current text architect to complete its current text. If we're running, stop the running loop. And set it to null. Then if the architect is not null, call force finish on it. Again, we'll need to make that function for the architect. So load up the architect and go all the way to the bottom and add force finish. This function will simply set the max visible characters to max and terminate itself afterwards. And with that, our segment works. So now an update where we originally advanced through the chapter file, just call the next command with a key press of any kind. That key will trigger the chapter to advance. And this is temporary, of course. We'll have other triggers soon, including clicking certain pieces on the screen. Make sure you've got a chapter file that uses segmentation following the rules you've made. Load it up in Unity and execute it. Okay, and I successfully have a stuttering dialogue system, so obviously something went haywire there. Clearly segmentation works because I is the first segment. It was just repeating, so I must have forgot to increment the progress. So let's look at handling line, and the progress starts at 0. Down here. Yep, after the segment finishes, I need to increment the line progress. Let's try that again. Okay, good. It appears to be working. Got our additive text there. My timed auto delay works. According to this line, it's some kind of light should be appended to the string next. And there it is. That's good. Alright, sweet. Now this next line should start. But it is not starting. Okay, time to investigate why that is. Apparently, it wasn't starting because the line was never acknowledged as finished, because I never set the handling line coroutine to null. Set it to null, and that should fix the problem and allow us to advance. I also had a wrong value here. My additive should not be if pretext is not null, it should be if pretext is not empty. Make sure that's good in your segment running loop. Now, there we go, override worked, which it wasn't before. There's additive, the timed delay. Again, time delay clear. Append, and the new line. Another auto delay there. Looks good. Alright, now it should bring up Raylene, and she'll use an additive segment. There we go. And additive. Sweet. That is perfect. Now I want to make sure I can skip my auto delays, so let's make a line that appends after 3 seconds. So let's delay just something random for 3 seconds. Make my tag W3. Okay, that's actually not going to append, that's going to clear it, but if I wanted to append, I'd say WA3. But here we go. Delay, 1, 2, 3. Go, yeah, okay, there it is. Now let's run that again, and I will stop it now. Sweet. Great. I interrupted the delay, and that is good, so that's very good, we can do that. Everything's looking great, but let's make sure we can execute the actions at the end of a line now, because we are not doing that yet. Go to the novel controller, and after the line ends, loop through every action and pass it into the handle action function. Also do yourself a favor and update your command file with the segments we've created and how to use them. Otherwise, if you're anything like me, you'll probably forget them later down the line. Now I'm going to make sure my actions execute at the end of the line by making a new line with an action at the end. I want to toggle hiding the scene, so that will be my action. Show scene false, using that blur picture, and reveal it after 1 second. There we go, text finished and the scene was hidden. Visible in 1 second again, that's good. Alright, so that is it, ladies and gentlemen. We have a smarter and much more convenient chapter scripting now. That should make it easier for you guys to write out your novel. The next episode, we focus on tags in dialogue, and we'll also cover making actions execute at the beginning of lines or even during segments as well. Tags will offer a ton of functionality and capability, so don't miss it. Until then, take care.